Our keynote speaker is, I would say, a worldwide known .NET expert, a frequent speaker at BASTA conferences. I'm happy to meet him here after 3 years, yeah, the last time we met here. And the title of his keynote is Unpopular Opinions in Software Architecture. And I would just say, Dino, please come on stage and explain us how to build the next Netflix.
Well, thank you, Sebastian, for the introduction. The point made about Netflix is not completely out of place, as long as if you consider the Netflix of the first 3 years of life, so the Netflix of 20 years ago. And if you look at that in that perspective, well, sort of. In fact, what has changed for me personally in this 3 years that kept us in a sort of limbo is that I stopped in first place being a frequent traveler, going out at conferences, doing trainings and things like that, and I had to go back to the hard work routine, producing software, and I'm now part of a new company, the same company that I worked as a freelance in the past, but now it's an established company in the sport tech industry. So all that I'm going to say in this keynote about software architecture, those unpopular opinions and the controversial statements you may hear in the next 30 minutes, still come from a specific perspective, which is that of the sport tech industry, in which the business logic that we face is changeable but relatively stable. The performance, the experience of users is much, much more important than the speed. They find normal to spend seconds, just exaggerating, but seconds in front of a screen as long as they go with the same routine, with the same processes that they used to do things before the digital transformation, so to speak, came their way. User experience is crucial for us, and things must work no matter what. I mean, I started, we had the platform going live in January 2021, and it was the first round of tennis tournaments after the pandemic, and I spent an entire week with nearly no sleep because I was working the 8 hours or normal day, and then with tournaments in Australia, I was awake all the night trying to fix things because you cannot afford, that was our business, to have an order of play or a schedule or a draw to be stuck. And I confess that I put my hands live on the production database, changing values to make order of plays or the Davis Cup in the fall of 2001 to start. Now we have reached a different situation. We have more people, we have consolidated platforms, and also we faced the startup dilemma. If you are a startup and you manage to survive as a company, to stay on the market, you don't have the time to build the flying unicorn product that will make you billionaire. At the same time, if you take the time to plan and build the flying unicorn product, you don't have a way to survive financially as a company. That's why startups need venture capitalists. But we are not a startup, not yet at least. But we are not yet a startup because we found a way to build some products. We have products. We survived as a company, and we even found investors. We are not. We were in sport tech, so we provide services to tennis and paddle in particular. We also have a ticketing platform for sport. We are not a software house. So we don't sell libraries, projects, we don't sell consultancy, but our products are based on software, and the services we sell in person at tournaments all over the world are still based on software for internal use. So the point of my keynote is, how do we write software? And again, keep the perspective in mind. I'm not here to teach you anything. I don't have anything to sell. I don't want to gain a particular exposure. I just reporting the experience of 3 years. In first place, we realized that we know the sport, and the tennis in particular, very, very, very well. We had a lot of conversations with the CTOs, with the managers, running the IT departments of women and men tennis associations, international federations, and we found out that we knew the business, their business better than them, as far as IT is concerned. So we know our stuff, the business domain. Sometimes it happened that we had made some good decisions, but very often it turned out that we went against the mainstream. So if you look at software architecture, if you look at the trends for web development, you see a number of statements being continuously pushed against the audience. You must be doing this, you must be doing that, this is the future, this is all, this is so 2015-ish, this technology, jQuery in particular. Yes, okay, this kind of things, we refused many of these unpopular statements, but not because we want to go against the stream, because for our own purposes, we found out that we could do things in a much simpler way, going against the stream. We like to call this pragmatism. And by the way, recently I also restarted a blog with a few articles for which the link is there on the slide. And because we're in Germany, and because of another project writing the history of artificial intelligence, a book project that I'm on these days, I started now again reading the life, the biography of philosophers of the past centuries. So pragmatism makes me thinking of practical reason and makes me thinking of the greatest German philosopher of all time, Immanuel Kant, and his popular quote from the critic of practical reason: two things fill the mind with ever new and increasing admiration and awe, the more often and steadily we reflect upon them. Software-based unit tests above my code base and monoliths within my code base. So guess what? These are the two crucial aspects of software architecture and software development that I'm going to talk about. A quick cost-benefit analysis from a very pragmatic perspective of unit tests, test-driven design, and then the battle between monoliths and microservices. Let's start with unit tests. Now, we don't do unit tests, if not occasionally. Should I go? I know from a reliable source, and I believe that it's also written somewhere on internet as well, that people at Stack Overflow also don't do tests, unit tests. So it's not because of us, because of Stack Overflow, okay? It's possible to deliver software that works in production without running regularly and writing regularly unit tests. For us and for Stack Overflow, it's much, much more relevant running integration tests. So making sure that the various pieces connect together. That in our context, that we are able to send the data back to a legacy system for them to calculate the rankings every midnight of the Sunday. It's crucial that we are able to push an old-style, obsolete XML every day so that they could update the website. And to make this work, we have to create mocks, and we created mocks to test. And then integration test makes these things work really with the true endpoints. So integration tests that we have not even structured and repeatable, but we make sure that whenever we have the need of a connection, everything works beautifully. And I can tell you, because that is exactly how it happened. The mobile application that all umpires in the women's tennis use on court, they are using now in Dubai this week, the test to see if the push of every single button could reach the platform that my team wrote that dispatches the information to all the takers, we tested this integration 3 times. 3 tests. Hey, push the button, yes, okay, I got it. Let me try again, I got it. Okay, it works, and it worked. It worked because the people who wrote the mobile app and the people who wrote the router, we knew our business, how we should work. So if you send me this JSON and I parse it correctly, and I realize, and in 2 or 3 times we see it, that if something comes null, we have to work around and set a default value, fix that. It works, and it never stopped working. We tested 3 times. No need, really no need for spending hours writing unit tests, because I don't have the unit test, so I feel dead. In a way, we realize that we operate like actors on stage. Actors, they don't have unit tests. They have to learn the script, and they have to play the script. They repeat the script until they feel comfortable, and they do it often and often and often. Or look at, I would say tennis players, but that's what they do. Their daily routine looks like unit tests because they repeat forehands and backhand and volley every single day. So that could be like unit test. But let's call rehearsal sessions until you feel comfortable that the code could work. And you are comfortable that in case something goes wrong, you're there and you can fix it. Now, the platform that went live, 95% feature complete on January, end of March was completely running on its own. 2 months in which a couple of people spent daily attention to check that everything was going okay. But we stay weeks and weeks in which nobody touches the code, because no bugs, nothing, no question, no new requirement comes up. It goes by its own. So the tennis, especially women's tennis, runs on its own. And we have no unit tests. Now, let's try to reflect on this. If it's possible to write code without unit tests as a part of the regular development cycle, does it mean that unit tests have no usefulness? No. Unit tests for sure have a cost. You have extra code you have to write. Let's assume, let's take for granted that there is value with unit tests, but there is also a cost. So the point is, are unit tests worth their significant cost? I believe that the 3 main aspects that take us to consider extremely useful unit tests are the fact that once you have a unit test battery, you have in a way self-documented the code. Because any new people that faces the code, looking at the unit tests can form a clear idea of which are the features and how the code is expected to work. So they may help developers to understand the purpose of each method and class in code. Number one. Number two, the unit tests, the overall family of unit tests, capture actions that should be, and results that should be considered as an invariant. So no matter how the code evolves, how the implementation changes, I expect to still getting this kind of invariant output. But now, are we really sure that if we pass the test, everything is okay? We'll get back on this in a few moments. Third point, with unit tests, because you have guaranteed for the previous point that any invariant behavior that is captured in unit tests can be tested for success, any refactoring you may apply can take place in a safe environment. So you are able to capture any regression, read any error, you fix something and break something else. If you break something else, that's regression. Unit tests that capture invariant behavior, as long as the thing you have broken belongs to the invariance, you get it, and you can fix and take one step further the refactoring action. Now, if we have tests applied regularly, we definitely managing complexity and the overall quality of the code comes better. Now, the question mark on the red sentence is, okay, sure that the unit test project is relevant to remove the question mark there. Yes and no. Let me spend a few more moments. Unit tests deliver a value, okay? But if you take the value out, so the possibility of getting regression, the possibility of identifying bugs, the possibility of having better code with well-defined boundaries, okay, you can achieve this with unit tests for sure, but it's not the only way. Unit tests, if not done properly, the point is the invariance. How many invariant conditions are you really capturing in your unit tests? I'm not simply talking about code coverage, which is just a quantitative unit. I'm not saying how many methods, how many scenarios you test on every method, on every class. I'm testing the behavioral relevance of the things you test. If those invariant conditions that you can capture running tests, if those reflect really the business relevance of the application. So it's a matter of behavioral quality rather than a quantity code coverage. A test that is not relevant for the business or for the expected behavior, but just checks, I don't know, a null condition here and there, or that an exception is thrown that never happens in code. It's just a number. It makes quantity, but it doesn't make quality. And if you are victim of the unit test hype, you can even risk to fall into a false sense of security. I passed the test, I have the test, I have all greens, I'm fine. No, if the invariants that form your test have not tested themselves. Then unit tests is code. Because it's code, it can be bugged. It can have a bug, can contain logical bugs. Can be incoherent, can be out of focus. It's anyway code to test and maintain and evolve over time. And it's anyway a lot of stuff. Because to have a decent coverage, whether it's just mere quantity or quality, it's a lot of methods you have to write. So if you have it's greater than one test per method per class. Test-driven development seems to be the natural way to have unit tests created with a significant or more significant behavioral value in the same process of writing code. You know, test-driven development, first write the test. For every method, write the test. Write the code that barely passes the test. Put the logic into the method. Which to me always seemed silly. But anyway, but that's me. If you want, I go because every time I say something too strong, and you want me to go, I go. Now, if you want to be a fanatic about unit tests, you must be able to write code that lends itself to be tested. So if you can write code that by design lends itself to be tested, this is much more important than having physical unit tests. And this comes with discipline. Test-driven development is a dummy way to is learning a mechanical method to move new people towards a programming style that ensures, in a way, pseudo-mathematically, that the quality of the code is greater. Because code that can be easily tested is code in which the boundaries between concerns are clear enough. And hidden dependencies are limited in number. So what it means exactly, testable code, so code that lends itself well to be tested. Essentially, it means that dependencies on external pieces of logic are well isolated, and every method does its job counting only exclusively on the input data it is passed. Sort of stateless kind of programming. You give me this input, I work on the input only, and I return an output. If I need some external behavior, some external piece of logic to process the data I receive, then that external piece of code should be abstracted to an interface and injected in some way, dependency injection, for example, into the method. In this way, it can be mocked up if you are a fanatic about unit tests, or it can be just put there and replaced if some part of the business logic changes. So much more than physical unit tests and much more than the practice of TDD, I strongly believe that a TDD mindset is what really matters. Practicing rigorously, slavishly TDD per se doesn't add much. It's a point. It's not necessarily a great point about any developer. It's anyway absolutely acceptable as a personal style of programming. So I'm not condemning at all who does TDD. But I don't want anybody come my way and say, oh, you don't do TDD, you're a dinosaur. That's it. Then, in our context, in sport tech, as I told you already, UI and UX is crucial for the simple reason that actual people working on those applications are not exactly smart people. They are the classic dummy user. And these dummy users have been used for decades to do their own things through Excel files, paper sheets, and they follow a routine, because for them, all that counts is that players go on court, all the information they need is captured. They have a process that the software must fulfill step by step. So the decent UX and the decent UI, but more than the UI, the UX, so the sequence of actions, honestly, it's not something that can be easily tested without putting your own hands, expert hands, on the user interface. Even though you can use Selenium or whatever kind of platform for JavaScript and UI unit tests, no automated test is realistically giving you the certainty that the experience is acceptable for the user. You have to try that with the sensibility, the sensitivity that you have by knowing the domain very well. And now, the second topic. Microservices. Disclaimer, also, similar to unit tests, I'm not a huge fan of microservices. But I'm not against microservices just because they are. The point is, what do you mean by microservices? What is exactly your definition? I have my own definition of microservice. And once, years ago, I had a talk at a conference called I Had Microservices and I Didn't Know. And at the end of the talk, a couple of guys from the audience came my way, approached me to say, look, but your definition of microservices is wrong. A microservice is something else. And the point was about the size of the service. So how large or small is micro? Once we clarify this point, we can decide what is the better, ideal software architecture that lends itself for scalability if needed in a given business scenario. Now, a definition that is widely accepted is that the microservice should have the same size of a bounded context. Bounded context is a concept coming from domain-driven design. And in domain-driven design, what appears in the beginning as the huge monolithic business domain is split partitioned in blocks. Each block is called bounded context and is a bounded context with its own ubiquitous language, its own implementation, and its own user interface, programming interface to be connected to other bounded contexts in the context map. That's it. So given this definition, and again, there are quite a few people in the industry that agree on this, a microservice is not that small, because it's a section of the entire business domain. It's not so small. It's plain service, web service, app service, deployed, autonomously deployed. The quote from the popular Fowler sentence, a microservice is a piece of code autonomously deployable. It's autonomously deployable. It's completely independent from the other bounded context when it comes to the choice of technologies. It talks with the rest of the world using gRPC, using REST, using a shared database, text files, whatever, blob storages, whatever. But once deployed, it's a monolith. It's one piece. It's a monolith. So microservice equals bounded context. Another camp says that the microservice has the size of a function, an Azure function, a Lambda function, end-to-end piece of code that from top to bottom gets input, runs whatever piece of business logic is supposed to run, making access to any sort of database or external service, produces an output, whether writing on some database or returning some JSON or whatever else. But if you take the statement, the microservice is the size of a function and has to be an autonomously deployable piece of code, things like security, testing, logging, transactionality are lost. And, oh yes, they are lost. But if we put another framework on top, we can have frameworks for distributed testing, distributed security, distributed logging, distributed transactions. Frameworks on top, on top, on top, workarounds that just add complexity, latency, and resources, both on the cloud and also skills. Because DevOps is unavoidable. You need to have strong DevOps engineers on the team. Everyone can just publish on Azure or on Amazon from Visual Studio. Push a button. Or if you have some sort of CI/CD, just push the Git repository. The build is built, the release is built on the server, and then manually or automatically is published. Just push a button. Everyone can do that. You don't need DevOps engineers, except for just setting up the CI/CD kind of things. But if you don't do this, it's a significant different story. The complexity increases. So first place, decide in your own environment, what is the size? What do you call a microservice? A service or a lambda? Now, monoliths. Monoliths are the devil's word. If you say, oh, monolith, it's unique piece of code, compact, deployable in a single step. If it works, if for your purpose, if you are Netflix and you just started, before you gain millions customers, a monolith works for you. If you have to do crude ops, you don't need. I mean, I really find it stupid, not even silly, just stupid, to showcase frameworks for microservices that create a to-do list. It's too simple. If you have to do something like a to-do list, crude ops, no matter the complexity of the logic, but just create, read, and delete transactionally, don't start with microservices. A time can come where you need the power of scalability. That's a different story. When it comes, you start from scratch. Netflix, Amazon, they were not built for scalability on day one. When they reached a size such that the existing architecture didn't work, or didn't work the way they wanted, they looked for and invented a different architecture. So if the simpler works for you, stay there. So I just wrote, I just noticed on LinkedIn, I think it was Grady Booch, so a big man in this industry, posting that, yeah, if you're a startup, don't even think of scalability in microservices. When you are much more than a startup, you can consider that. And instead, what I see is that in the industry, oh, microservices, 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 as it's the only way of conceiving software. Now, monoliths are considered a bad term because you think of them as interspersed, interconnected, intertwined code flows. But if you follow the rules, design rules of domain-driven design, the layered architecture, or call it clean architecture, or even feature-based architecture, or hexagonal, if you take seriously the separation of concerns, Nothing is wrong. We have a monolith. Okay, modular, well done monolith. And with that, we happily run the tennis worldwide. We don't even have any special, we have just one instance of our application, not even multiple instances running on Azure. The only thing we have significantly heavy is the database, the DTUs of the database. Everything else is absolutely normal, could be a demo example. And all the tennis and paddle run on top of this kind of application. Like Stack Overflow, things can be simpler than gurus, not me, I'm not a guru, sometimes say. Anyway, if you want to go with microservices, lambda size, that's a different story. Then you probably need to take a serverless environment and build what is defined, labeled as a cloud-native application, which is a completely different kind of application. But it's in the folds of articles and posts that mention this, you find, well, this is, if you have a high traffic, if you're an e-commerce site, if you are streaming site, but not if you're doing crude ops. Okay, now the story, to finish off, the story about Netflix. 3 years ago, we received the process, the contact, the task of building a platform for running operations in tennis, and we thought in the beginning, oh, if it's like we are Netflix now, because we can really apply all the beautiful theory that is on LinkedIn. So create a front end with Svelte, Angular, Blazor, then put a bus somewhere with handlers. Maybe we can go with end service bus with sagas, those beautiful things. Then we have a gateway with GraphQL inside, and then we interconnect all the various blocks. We have blocks for configuration, for statistics, for the calendar, for the results, for the synchronization with LED walls, database of players, database of messaging, the receiver from the outside. We can receive data from the live through an API, and then we dispatch the information internally. Everything is a microservice. So reducing the architecture like a front end, a gateway, and then a Lambda populated serverless environment. If you were Netflix, but we were not Netflix at the time, so we went with this. Front end, ASP.NET Core, plain Razor pages. We created a number of application service. Some other literature calls it mediator handlers. We didn't use mediator, the framework. But conceptually, we have those application service. Application service is a DDD term, by the way, that go straight top to bottom to take care of the configuration statistics. So they are well-isolated modules, even though they are just individual classes in the same project. They could go to a class library. They could even go to a separate app service. But even if you put everything into the single project, they are well isolated from one another. And then repositories, which is the only place where we know about the connection string and the database structure. This makes up for horizontal layers: presentation, application, domain, infrastructure, the ABC of the layered architecture as it comes out from domain-driven design. We can argue whether a vertical segmentation, feature-based, could make sense. In fact, we are now seriously, as the system is going to evolve after 3 years of life, we are seriously considering, because of a significant increase of complexity, to split vertically, essentially column by column. But that's an idea. So all this thing is one monolith to be deployed, and it makes sense because at most we have 10 concurrent users, and tables are read and written at most every few seconds. Why a microservice architecture? At the same time, in our complete, huge business domain as a company, this is just one small circle. And we have and all around it has many other distinct applications. So in this context, we are a service or a microservice with the size of a bounded context. So the first thing, and the only thing probably is, what is the size? What is your definition of microservice? Thank you very much for your time.
Thank you very much, Dino, for making unpopular opinions popular. Thank you so much. And now we've learned how to build the next Netflix, or really to understand what should be the right dimension to think about, right?
I mean, it's just my opinion. Unpopular, but opinions. I don't want to force anybody to do anything. I'm no longer a consultant, so I'm just reporting the experience of these 3 years in which we have actually built a ticketing platform and the operations management system for men, women, and international and young junior tennis players. So we manage for all the circuits the subscription of players to various tournaments, transportation, bookings, and things like that. And we are doing the same, including ranking and the full hand-to-hand system for paddle, with no legacy in the middle, completely from scratch for paddle. And something, yeah, I had to work heavily and think that this 30 minutes have been just the summary.
If you got more questions, please don't hesitate to talk to Dino.
Sure.
Off stage, please, yeah.
Absolutely.
I'd like to welcome all of you, of course, at 17:45 for 5:45 to the expo reception again over there. And then later tonight, there's on this stage again a panel, not a panel discussion. It's 3 web development experts talking about the future of web development. Enjoy the afternoon, have great sessions. Thank you very much, and thank you very much, Dino.